No, I'll be checking them before you go. Okay, here we go, 6-3.
You know what I mean? But it was like, he's talking it up a lot.
A meeting?
Okay, every single one of these sections has started out exactly the same. Find the confidence interval for the population. In the last two sections, it said population mean, large sample. Population mean, small sample. Now we're going to find the confidence interval for the population proportion. Proportion is just a percentage. What percentage of the population believes this, does this, so proportion. Okay, the symbol for population proportion is the letter P. Okay, so I'm going to give you the steps right now. This one's a 4-step process. First, you have to check to see if your sample size is large enough to be normally distributed. We usually say you need 30, but that's just for finding means. For proportions, it's different. So your first step is to check to see if the sample is large enough to make a normal distribution. And what you check is your sample size times p hat. I will tell you what p hat is in a minute. That has to be greater than or equal to 5. And n times q hat also has to be greater than or equal to 5. No. So second step, I should have these reversed. This should really be your first step, that should be your second step. Find the point estimate for P. Remember, when we were doing the mean, the point estimate for the population mean was our sample mean. We said that the population mean was going to be somewhere around that sample mean. Here, the population percentage is going to be somewhere around the sample percentage. So the point estimate for the population percentage is p hat. The sample proportion. Which we call p hat. And the way you calculate p hat is you take your number of successes over your sample size. So x is number of successes, n is sample size. Several. Now, if p hat is not known, no, I'm not going to put that here. No, change my mind and put it someplace else. Okay, then your third step is to calculate your max error. So, remember before we were doing the 3-step process. Here we got a 4th step, and the only thing that's extra is we got to check to make sure that it's normal. But our max error formula is slightly different than you've seen. Always going to be a z-score, if it's a normally distributed from step 1. So you're back to that little table from 6-1. So the z-score for your confidence level multiplied by the square root of p hat times q hat over n. And that whole fraction is under the square root. And then your 4th step is to write the interval. So that will be p hat plus and minus your big E that you found in step 3. Ready for an example?
Wait, what was the one thing that you were going to add?
Later,
Okay.
when we do sample size. It doesn't apply here. I don't know why I've got it here. Okay, example 1. Construct a 90% confidence interval for the proportion of adults that think Abraham Lincoln, so we'll go with Abe Lincoln, was the best president.
90%, 100% of adults have met it, so.
And this is the data. There was a survey of 1,470 adults, and 98 of them chose Abe. Okay, well there's your given information. So my first question is, what word in this whole given information is telling you to go to this section of your note card? Proportion. You're finding the confidence interval for the proportion. Doesn't say mean this time. Every problem we've done up till today said find the proportion average, the proportion mean. Or not the population mean, but now we're doing population proportion. So, now we're going to follow our 4 steps. And like I said, I really should have had step 2 as step 1, because you need that p hat to do step 1. So let's find p hat first. Let's do step 2 first. We need the point estimate for p, which is p hat. So first, let's find p hat. So, how many successes did we have? The p hat is, I'll write down x over n.
The 98% or just
98 people. So, how many successes did we have? Or did they have? They had 98 successes out of 1,470.
I like those odds.
Okay? You can go down to a decimal here, or leave it as a fraction. You're going to be more accurate if you leave it as a fraction. So we're going to leave it as a fraction. So now let's check. Check to see if the sample is big enough. Check for normal. And that said check n times p hat. That had to be greater than or equal to 5.
Is Q the number of failures?
Mm-hmm. So n was 1470. Multiplied by p hat. Well, p hat is 98 over 1470. So what are we actually finding when we multiply n times p hat? The number of successes. If your number of successes is greater than or equal to 5, then you got to check your number, essentially the number of failures, which we'll find out. So 98 is okay.
what just happened?
It cancels out.
Yes, it cancels
Yeah.
out. So when they said do n times p hat, you're really looking, at the end result is the number of successes. Now we check n times q hat. What do you think q hat is? Failures. How many failures were there? A lot. Because all you get. So if we subtract 100, that would be 1370. So 1372. I just subtracted 100 and then added 2 back on. So that's definitely over 5. So we're good to move on.
Only I had one people on the page.
Okay, so our third step, we're ready to calculate max error, big E. So, the formula says take the z-score for your confidence level. Do you have it memorized? Do you have the z-score for 90% memorized? 1.645. Yep. 1.645. Where are you people getting that from? The table from the notes way back. And then we're going to multiply that by the square root of p hat times q hat. So that's those two fractions. This is more of a calculator challenge than anything. And then divide by the sample size. N, right? Yep, 1470. Okay, I would try it on your calculator. I would do this part first. Do all that multiplying, then square root that answer, and come back to multiply by 1.645. See, it's all calculator work.
Parentheses everywhere.
What'd you get then? Yep.
Yeah,
Here you
then
did
have to
something wrong.
multiply. You just have to multiply the 1.5.
Oh, yeah, what'd you get?
How far are we going up, Sharp?
We're going out 2 places. Do all 3. Let's go 3 places. The book's been doing 3 on
Zero,
those.
1, 1.
How?
You guys don't.
Clearly.
I will show you what I would do.
Oh.
Do you see your mistake yet?
So that-
No.
Still got it wrong.
Okay. I can do mine real quick. I would, if I was doing this one, I would not bother with that square root at this point. I would take 98 divided by 1470 times 1372 divided by 1470, get an answer. Divide by 1470, get an answer. Square root that answer. Multiply it by 1.645.
Okay, yeah, but I did.
So, just keep hitting enter a bunch of times, you don't have to use parentheses. Doesn't really matter. Whatever makes you comfortable. Okay, now we're ready to write the interval. So we are going to take the p hat plus and minus our big E. And the book does do all of these answers in decimals. So our p hat was a fraction, 98 over 1470. Let's get a decimal for that at this point. Point what? 061?
I just said repeating, so it's
Oh, 67. Plus or minus that point 011 that we just got. So then we turn that into 0.078 and 0.056. So we would expect the percentage of the population to be between about 5.5% and 7.8%. we're going to do another one because the given information is going to be slightly different than this one. And I'm going to change the percentage on you because they like to do that. And then we've got minimum sample size to do. Okay, so. Example 2. Construct a 92% confidence interval. Not very common thing to do. It's usually 90, 95, and 99, but we're just going to throw you a little curveball, see if you remember how to find the z-score. Confidence interval for the proportion of the population that has high blood pressure, of adults with high blood pressure. They did a survey of 500 people, and they found that 4% had high blood pressure. So, two things in here make this different than example 1. First of all, that it's a 92% confidence interval, and I didn't tell you how many successes there were. I actually gave you the percentage of successes. So, let's first find p hat. And I said p hat was the number of successes divided by the sample size. Well, I don't really need the number of successes because I've already got p hat, the percent of successes.
Oh.
So the p hat is 0.04, 4%. So that's what makes it a little different. It actually did the work for you. So now we have to check for normal. And that's n times p hat has to be greater than or equal to 5. So that's 500 times the 4%, and that is 20. That's good because it's greater than or equal to 5. And then n times q hat, do we really need to check it? Because it's going to be the rest of this, 480. Because q hat's going to be what's q hat going to be?
480.
But what's the q hat value? 96. The rest of the 100%, either 4% successes, 96% failures.
Is there ever been a situation where that was?
Where it wasn't 5?
Yeah, where the P was okay with that.
Potentially, yes. Yes, that could happen. Okay, so third step is to calculate your max error. Okay, I need the z-score for 92%. You can do it. Because those three numbers we gave you, you found those off of the table. You remember how we found those z-scores. Remember what we're finding. We're finding the middle 92% of our population.
So we put 92 in the middle.
Put 92 in the middle. So you find 0.0400 on your table, or the closest thing to it, and then it's going to be that positive value. So we're on the negative side of the table. Your z table, which I don't have, and I did change that then from this one. So you will have to help me out. Maybe it's down here. No.
26, 5, 5, 4. Well,
I got 1.75.
no.
You're looking for 0.0400.
120.
Lucas, you're looking into the 4-digit numbers for .0400.
Oh, that's point zero zero. So.
You want this to be .0, not up there.
What?
.040.
Oh.
Area should be that, so right here.
What?
So what B4 is that? Yep,
Yeah.
right here.
These ones?
Yep. Again, what'd you tell me was negative? No, still on. So positive 1.75 is what goes into our formula. And then times by our square root. So this time we've got the decimals for p hat and q hat. So 0.04, 0.96, and then 500. You let me know what you get, because I did change from my note. 0.015? Are we in? It sounds reasonable.
No.
No?
4.38.
That's what we got.
What are you guys getting?
0.15.
Oh, yeah.
Do I need to do it again?
Oh, I don't think it's wrong.
You got some? You found yours?
That's the correct answer.
Okay. So then we're ready for our interval. So our interval will be p hat plus and minus big E less 0.04 If you were to see this on a TV or an advertisement, like when you see they'll give, a lot of times now they're giving President Trump's approval rating, you'll see it at like, well, it won't be this low, but they would advertise this as 4%. It wouldn't be that low, it's the 30s, but it's not down at 4%. But then if you look, they'll say it's around 4%.
It probably is in some place.
Look at the bottom of their survey, they'll say plus or minus 1.5% is the way it would be given. They don't do it like this, they do it like this, 4% plus or minus this. So that's how you'll see it on the, be looking for it, you'll see it right now on those approval ratings. Maybe I can find one and I'll show you. But our book does this way, real life does this. Because people understand this more than they understand this. Alright, last thing we're doing is minimum sample size.
Couldn't say that. Oh, wait. How much more is there?
Don't know. Okay, we're going to take that big E formula and work it backwards so that moves in. Okay, so this is just some exercise and some algebra. You really don't have to regenerate this again. The last line is what you're going to want on your note card. But this is good practice. Solving for n. What's going to be your first step? No, not yet.
Multiply.
Divide by z.
Divide by z, right, divide by.
So we've got e
I think you know everything, Michael.
over z. Now what? Now square both sides. So you've got this fraction squared. So we will have e over Z squared now what? Multiply by n to get that out of the denominator here.
Are we trying to find P?
We're trying to find n. But we had to get that out of the denominator. Now what? What's our last step?
Divide by EC.
Divide by this fraction squared, which is the same thing as multiplying by its reciprocal.
Yep.
So n will equal p hat q hat times the reciprocal of this thing squared. And this is where, if you don't have any preliminary data, no p hats given, this is where, if p hat is not known, you want to maximize this, and it would be use p hat equals 0.5.
Is there an actual name for that?
P hat, that is the actual name. I'm not making that up.
Mathematicians, I don't get it.
Okay. P hat. Okay, last example.
Me hat.
Oh, there's the me hat.
That's what I keep.
They should have.
All
Exactly. Me hat does not be.
large
I'm gonna fit it. That's
Oh, yeah.
of a sample
Yeah. I'm gonna fit it here.
is needed
Me too, Tori.
to be within 0.03 of the population proportion for a, let's keep the one we just had, 92% confidence interval. Okay, this is the second minimum sample size formula you had. So how are you going to know which one you're supposed to use? The word proportion tells you to come to this section of your note card and use this formula we just had, which was n equals p hat q hat z over e squared. So you've got to fill in 4 values.
What would we do without numbers?
A whole lot of memorizing, or
Okay.
not much math.
Right on the desk.
Okay, p hat and q hat. Did I give you p hat and q hat? Did I give you any sample information? I did not. Sometimes they do, sometimes they don't. If they don't, what do you use for p hat and q hat? 0.5 and 0.5. If I had given you data, knowing that the sample proportion is whatever, you use that. But if it's not given, you use the 0.5 for p hat and 0.5 for q hat.
Wait, you would use 0.5 for Q hat as well?
Yep, because if there's 50% successes, there's 50% failures. They always got to add up to 1. Yep, okay. How much error, what's my z-score for 92%? We just had it. What was it, 1.75? How much error are we allowing? 3%, within 3%, that means they're allowing an error of 3% on either side. So your big E is 0.03. And remember, this is a sample. If you were doing this survey, how many people would you have to talk to?
151.
Mike says 851. Is he correct?
Yeah.
What was the decimal?
0.7.
Oh, so it did round up. Even if it was 850.2, you still give me 851. Otherwise, -1 for you on your test. Okay.
So what
Why
am
don't
I
I just
reading?
half? They're like,
Page 280.
Oh my gosh,
I see it.
yeah.
What if it's-
820 people.
10 through 24, even.
Okay.